Hello everyone, and welcome back to my channel. If you're new here, I am Vatsal Security, and today, I'm excited to present to you an awesome new tool that has just been launched in Kali Linux, Netscanner, TIA 2.5. This sets the tick rate to 2.5 ticks per second. The tick rate determines how many ticks, iterations, the scanner processes per second. In this case, the scanner will perform 2.5 operations per second. This affects the speed of network discovery. Higher tick rate, faster scanning. Lower tick rate, slower, but possibly more accurate scanning with less network congestion. Okay, let's see how actually it works. Let's take a review on it. Open terminal and start installing the tool using command apt-get install netscanner and wait for the files to download. Run the tool using netscanner-t 2.5-f15. See, we cannot control the tool using mouse pointer. We have to work with keyboard only. So see the red mark on every command. The tab button on keyboard means switch from one tab to another. What does it do? This scans the connected network. In our local network, automatically detects the IP of the machine. If we press S, so it starts scanning over the local network. If you have Wi-Fi adapter supported monitor mode, it will also scan the Wi-Fi networks. With the range, I am using Alpha Wi-Fi network adapter. In the packets options, it starts automatically captures the logs of RP, TCP, UDP, ICMP, ICMP6 with time, and we also can export this for security monitoring review. You can even scan the open ports and close ports using Network Scanner tool. By pressing S, you can see the red mark on scan port. Indicates if there is any open ports detected. It will display on screen. And remember that it scans the subnet from 192.0.0.0 to 255.255.255.224 range of IP. Now come to Discovery tab and press E button to export the entire report. And let's check it out what it captures and saves on machine. Now open the RP packets file using mousepad command and copy the file name. Network activity. The log file is capturing network traffic. Specifically, it is capturing ARP requests. This is likely a result of a network scanner, like the Netscanner used before. ARP requests. This scanner is sending ARP requests from each machine and is logging their MAC addresses and IP addresses. This is likely for discovery and is also a common way for malware to discover hosts in a network. Repeated activity. Many entries with the same MAC address and IP address pair are appearing close together. This suggests a device is actively communicating on the network using a specific IP and MAC address pair. Time sequence. The log entries are in chronological order, starting with the earliest and progressing to the most recent. Network interface. All of the log messages pertain to the ETH0 network interface. Device information. The file contains information about devices found on the network, as represented by the IP and MAC address. Vendor information. The vendor information is inferred from the MAC address using a MAC address lookup database. The vendor for both discovered devices is VMware Inc. The ports that are being used for communications by the host, 192.168.95.131 are high, indicating this may be a server communicating to the client on randomly assigned ports. The source port 53 coming from the host 192.168.95.2, and the random destination ports indicate this is most likely a DNS request. The requests are being sent to the host, 192.168.95.131. Many of the packets are originating from port 53 of the source IP 192.168.95.2. The server host 192.168.95.131 is using random high ports in the thousands. There are a number of messages with source and destination ports swapped, but otherwise using the same two IP addresses, suggesting two-way communication is occurring. Most if not all of the packets are a length of 20, which are likely just TCP/ACK packets. Network analysis. Understanding TCP communication patterns. Troubleshooting. Debugging issues with TCP-based applications or services.